Welcome everyone to today's session of Strategic Farming. Let's Talk Crops. This is where we give research updates for kind of our winter sessions to give you ideas on what to look forward to this upcoming growing season here. These sessions are brought to you by University of Minnesota Extension and generous support from the Minnesota Soybean Research and Promotion Council, as well as the Minnesota Corn Research and Promotion Council. Today's session is going to be on our topics about insects in corn especially, so keeping track of changes related to our corn insect challenges here. So with that, we have Dr. Fei Yang on. He is our corn extension entomologist at the University of Minnesota. I'm your host and moderator for today. I'm Anthony Hansen. I'm a regional extension educator in integrated pest management based out of Morris. So with that, I'm going to turn it over to Dr. Yang, and we'll let you talk about what's going on in the corn insect world. Any updates you've been having, especially in the research you've been doing the last few years here in Minnesota.
Thank you, Anthony, for the introduction, and I'm very glad to be here. So today, I would like to talk a little bit about our corn insect pests. Let me share my screen first. Okay, so today, I would like to give some research update for management of those corn insect pests. As introduced, my name is Fei Yang. I'm the assistant professor here at the University of Minnesota for almost like 2 years. So for the major corn insect pests in Minnesota, actually, we can divide them into two groups. One is below ground and one is like above ground. So the below ground, these insects are from Coleoptera, and we have some major insect pests here, western corn rootworm and northern corn rootworm. And we all know these are the two majoring insect pests for the corn production, like in corn belt and also like in Minnesota. And for the above ground insect pests, and most of these are coming from Lepidoptera, and we have like old traditional, very important insect pests, European cane borer, and also we have other corn earworm, armyworm, and black cutworm. So first, I would like to talk about the major pests here, like two corn rootworm species. And both western and northern corn rootworm, they have similar life cycle. So from egg, larva, pupa to adult, and the larva is the most damaging stage, and it has about like 3 different instars, and the late instar larvae will cause like significant damage, and they will feed on your roots. So on this slide, and on the right hand, you can see these are like big larvae of corn rootworm. These are first, second, and the third instar, and on the left hand, and the circular yellow one, and you can see the larvae, they are feeding on the roots, and they prune the roots to the node, and for one node, and you can see no roots left over there. So these larvae cause significant damage to the roots of the corn plants. And this kind of damage can cause a significant yield loss, because without roots, so this will affect the water and the nutrition uptake for the corn plants, which will negatively affect the development of these corn plants. And because of undeveloped system for the root, and these roots are very susceptible to the water or to wind, and these plants can be lodged and in the field in the open conditions. In addition to the direct negative effect for yield, and these root damage can also cause indirect yield loss, such as photosynthesis problems, and also because of larger plants, you will have pollination problems. And finally, when you do the harvest with combines, and you will have difficulties for those machines to go through the field. And also because of the root damage by those corn rootworm, these can also cause a secondary infestation of those passengers will affect the health of the plant. So in addition to the root damage, rootworm larvae damage, and sometimes you can have some damage from adults. And here we show some pictures of the corn rootworm adults feeding on the tassels, silks, and this will cause pollination problems also. And if sometimes you have heavy infestation of adults on the tip of the ears, and they will cause some damage over there, and this can create some secondary infestation of sub-beetles and also some molds. So this is the field in Clearwater County in 2024, and we see lots of northern corn rootworm infestation there. If you look at the left hand of the picture, and this corn ear is heavily infested by northern corn rootworm. And when we peel the husk, and you can see most of the kernels and to the bottom, like to the middle of the ear were damaged by the northern congrutum beetle. These are damaged by the congrutum, not by birds. So we can see sometimes if we have heavy infestation in the field, and these adults can also cause significant damage for your comb production. So for Western congrutum, this is most abundant in continuous comb fields. And for the adults of Western congrutum, is not that mobile. So most of these adults are traveling within the fields or between comb fields. And we have documented rotation resistance for Western congrutum, and we call these variant. So for these rotation resistance Western congrutum, normally they lay eggs in the comb fields, but these variants, the adults can lay eggs in non-comb hosts. So that means if you do the rotation next year, the eggs will hatch in your field and it can still damage your comb plants. And for northern congrutum, you can see these in both continuous and also rotated comb fields. And compared to western, these northern adults are more mobile. That means they can travel long distance. So sometimes you can see lots of adults feeding in your comb field. So these adults may not originate from this field. They may be coming from other fields. And also for rotation resistance, we are also for northern congrutum, but different mechanisms. We call extended dipoles. So the adults of northern congrutum, they lay eggs in comb fields, but these eggs won't hatch next year. So when you do rotation, so these eggs can still be there. And 2 years, even 3 years later, when you go back to comb planting, so these eggs can hatch and they can still damage your comb plants. So if you look at the right here, so these are the cold tolerance for Western and the Northern congrutum, and we can see the Northern congrutum are more cold tolerant compared to Western. So if we look at the minus 17.5 degrees Celsius, and we have about 100% of Western were killed. And however, for the Northerns, only 20 to 50% were killed.
So Fei, if I remember right, that's negative 17 Celsius. That's about 0 degrees Fahrenheit, if I remember right. And I know at Morris, we got about 5 degrees for soil temperature. That was back in January. So yeah, hopefully we're getting a little mortality there. But yeah, just context for listeners there.
Yes, yes. So the soil, so most of the eggs laid by the Western or Northern congrutum, during 4 to 8 inches, and if the soil moisture is okay during the adult activity, and if it's dry season, probably more deep, up to 12 inches. So it totally depends for the environment, and we will cover those a little bit later in my talk. So for management right now for these rootworms, we have several tools. So the most used are the BT traits and the crop rotation. And also we rely on some chemical insecticides, and these can be applied at different ways. For example, soil at planting insecticides, and we can also use seed treatments. And sometimes you can use foliar insecticides for adult control. So first, I would like to give a little bit update for the management of congrutum using BT traits. So here I summarize all the traits here for BT, and right now in the market, we have 4 BT proteins and 1 RNI technology, and these 4 technologies total consist of 3 different mode of actions. For the hybrids, in the market, these are the combinations of these different mode of actions. So the first mode of action is cross-read proteins. We have 3 different ones, but these are similar in structure. So cross resistance can happen among these 3 cross-read BT proteins. And the second mode of action is cross-34-35AB1 BT protein. And right now it's named as GPP34 and TPP35AB1. And the last mode of action is RNI technology. It targets the SNF7 genes of the congrutum larvae. So for pyramidal BT cone in the market, it expresses at least 2 of these mode of actions in a single plant. So that means if larvae need to be resistant, they need to overcome 2 of these mode of actions. That makes these hybrids more durable in the market for control of congrutum. So here are some experiments we did in Lambton, Minnesota, and we test the efficacy of different BT and non-BT traits. And in this study, we use the VT double, it's non-BT, and the Smart Stack contains 2 crab BT proteins, Smart Stack Pro and VT4 Pro. In addition to the crab proteins, we also have the RNA technology. So if you look at the figure here, the y-axis is a nodal injury scale based on 0 to 3 AVA state rating, and the x-axis are different traits. And we have 2 studies here. So the results of these 2 studies are almost consistent. And if we look at the non-BT, the BT2P, it has like significant damage. And in the first trial, you have almost 1.5, and the second trial almost 1. For the like Smart Stack Pro and the VT4 Pro, and if you look at here, and we can see significantly reduce the damage compared to the like VT double Pro, that's non-BT, and all these are below 0.25. That's the economic threshold used for rootworm. However, for Smart Stack, we see a little bit more damage, but still like reduced compared to non-BT. That means in this location, the rootworm probably have some resistance to crab-BT proteins. But anyway, the BT traits are still effective for management of the cone rootworm. So here we summarize the resistance of Western cone rootworm. So as we all know, like the traits was first commercialized in 2003, and only 6 years after commercialization, the field resistance was reported in Iowa first, and then this resistance was reported in other cone-belt states like Iowa, Nebraska, North Dakota, Minnesota. So specifically for the resistance of Western cone rootworm in Minnesota, it has been documented in Yellow Medicine County, Rock County, Brown County, Moore County, and Redwood County, and these are just the published data. However, there are lots of other like cases not published. So the resistance of Western cone rootworm to BT traits is widespread across the state. However, that doesn't mean every population is resistant. There are still some populations like are susceptible. So the resistance status for Western cone rootworm is like field specific. So this is the field we visited last year in Moore County. So this is a non-BT cone. It's a continuous cone field. And if you look at the roots, you will find like no roots left on the nodes. So that means the pest pressure was significantly high in that area. And then we visited another field. So this is like a second year cone field, and it's a BT cone with like class 3 and the class 34, 35 AB1 BT proteins. And if you look at the plants are stand by here, so this though most of the plants were large. So we dig the plants and we check the gene expression and the root damage, and I found they express BT proteins. Also, we found like severe damage of the cone roots that confirmed the resistance problems for Western cone rootworm in that location. So as you mentioned, like for Northern cone rootworm, resistance is not like widely reported as like a Western cone rootworm. And until now, we only have 2 reports. One is the population collected in North Dakota in 2016, and the other recent one was the population collected in Meek County, Minnesota in 2019. Other than that, we didn't have any like public reports about like a Northern cone rootworm resistance to BT proteins. So here is a little bit summary for the like management for cone rootworm with BT traits. As we mentioned, right now we have like several mode of actions, but the crab proteins for both class 34 and 35 AB1 and class 3, they are not very highly effective due to resistance problems in some locations. And we only have RNA technology. That means the selection or like risks for this technology is high. But the good news is there are some new technologies in the pipeline for the industry. So we have class 75A, VIP4, and IPD 072AA, and these will go to like a new cone hybrids and can help provide like additional control for cone rootworm. And this is a new trait under registration under EPA with like 3 totally new technologies: RNI, class 75A, and VIP4. Totally get rid of the 2 older class 3 and the class 34, 35 AB1 BT proteins. So the second management strategy is a crop rotation, and in the cone belt, the most used is like a cone and soil rotation. So here we would like to look at some data about the effects for crop rotation for management of cone rootworm in Minnesota. So the y-axis here is Western cone rootworm beetle per crop per day, and the axis are different years with BT and non-BT traits. So first, if we look at the BT traits, the white bar here is the first year cone, and the light blue bar is the second year cone fields, and the dark blue bar is 3 or more years continuous cone fields. And if we look at the data from 2021 to 2024, we found that the white bar, the first year cone, we have very low pressure. However, for the second year cone and the third year cone, or more years, continuous cone fields, we see the insect pressure is higher compared to first year cone, even you use BT. So this study suggests that the rotation is still very effective for management of Western cone rootworm. And these populations for Western cone rootworm, they are resistant to the BT traits. And similarly, if we look at the non-BT cone plants of non-BT cone fields, and we found for first year cone fields and some of the second year fields, we have low insect pressure. But for the 3 years or more continuous cone fields, we have high pressure for Western cone rootworm. So if you look at the distribution of the Western cone rootworm, it's distributed across the country. And if you focus on the orange map here, so these are, we call as I mentioned before, these are variants. So that means these Western cone rootworm populations, they can lay eggs on non-cone hosts during the growing season. So this variants has been reported in Indiana, Illinois, and Iowa, as well as in some areas of Wisconsin and Michigan. And it has never been reported before in Minnesota. However, things are changing right now. So during July 2024, in a first year cone fields, and we found a significant damage of the cone roots. So we visited the fields, and we found most of the insects there are Western cone rootworm, and this field was planted with alfalfa for the last 7 years. And as you mentioned, this is a BT cone field. So we dig the cone plant and bring them to the lab. We check the root damage, and also we check the expression of these BT proteins to make sure these are not refugee plants. They are BT plants. And yes, they are BT plants. And also they have significant damage by the cone rootworm. So this probably suggests we have some rotation resistant populations in that area. Plus these are BT traits. So these rootworm species, they have dual resistance mechanism, both rotation resistance and BT resistance.
Hey, I got a question for you on that last field. What was the proximity of other fields there? Were these plants taken from the middle of the field? Was there corn surrounding it in somewhat close proximity, or was it a ways away?
So these plants actually were sampled during the in the middle of the fields, not from the edge. So we checked another field nearby. It's a soybean field. So we went to the soybean field. We checked the edge, also the middle of the soybean fields, and we found a significant of Western cone rootworm here as so-called with red here. Probably maybe you cannot see or red. So these are a Western cone rootworm. So they were feeding in the soybean fields with significant damage. So these it's high chance these adults will feed here and lay eggs in the soybean fields. So next year, that means in 2025, if you do rotation back to cone, and probably you will have problems. As we mentioned, in this area, the Western cone rootworm, they are both rotation resistant and BT resistant. So even if you use BT traits, probably you can suffer some damage. So by the end of the season, I got another report for another 3 first year cone fields, 2 non-BT and 2 BT. So all these fields were damaged significantly by Western cone rootworm. So all these evidence probably confirm the rotation resistance of Western cone rootworm in Minnesota for the first time in 2024. Now we switch to northern cone rootworm. And for the crop rotation, so first, if we look at the BT traits, and we can see either for first year cone, second year cone, or third more years continuous cone field, we have low pressure. So that means these BT traits are still effective for management of northern cone rootworm. And then when we look at the non-BT traits, and we can see some strange things in 2023 and 2024. For this white bar, we have high population for the first year cone fields, compared to second year and 3 or more years continuous corn fields. That means we probably have some rotation resistant problems here. And for the northern corn rootworm, it's extended diapause. And if we look at the distribution of northern corn rootworm and focus on the dark blue one here, so this is like the rotation resistant, we call extended diapause. And these kind of insects mainly like distributed like in Minnesota, Iowa, Nebraska, and South Dakota, and some areas of like Wisconsin. And for extended diapause, like northern corn rootworm, initially it's only like discovered in some small area in the south part of the state. However, like recently, this problem fluctuates, and the northern corn rootworm extended diapause population expanded to new areas. In 2023, it's like in west central and northwest Minnesota, and during 2024, it has been reported as far north as like Grunty, Vicky, and Otter Tail counties. So here is a summary like for corn rootworm management for like crop rotation. As we mentioned, right now we have both rotation resistance for western corn rootworm and northern corn rootworm confirmed in Minnesota with different mechanisms. For western corn rootworm, we call variants, and for northern corn rootworm, we have extended diapause problems. And especially for some, that means for some populations, we have like a dual resistance for both BT resistance and the rotation resistance, and particularly in western corn rootworm. And as you mentioned, the western corn rootworm has more widespread BT resistance compared to northern corn rootworm. So these will create like great challenges for management of the corn rootworm complex with the most like adopted tools like BT technology and the crop rotation. And then I would like to focus a little bit about like chemical insecticides for management of corn rootworm. So first, I would like to talk about the soil insecticide. So this is a study conducted from 2020 to 2024, and we recently submitted a paper to crop protection for publication. So we evaluate this efficacy in long term with different insecticides from different groups at different concentrations. So here are some list of the insecticides from group 3A, group 4A, group 30, as well as those like for group 1B organophosphate. So if first we look at the concentration effects for the same insecticide with different concentrations, so we did this study in 2020 and 2023 with different mode of actions. So if we look at the group 3A first ever and the group 4A in 2020, and we didn't find any differences among different concentrations for these two insecticides in terms of nodal injury scale, percent of lodging, as well as yield. So suggesting like the concentrations didn't change too much for rootworm management. And similarly, in 2023, we use like several concentrations of capture ranging from 8.5 ounce per acre to double the concentration to 17 ounce per acre, and we didn't find any differences for these three parameters. And the same thing for the like insecticides from group 30 and Eurisma, and they are similar between different concentrations. And then we focus on different like pyrethroids. So we tested these like in 2021 and 2022. So in 2021, compared to untreated like chick, we had all these like group 3 insecticides. They didn't significantly reduce the damage for nodal injury, lodging, or increase the yield compared to the untreated chick. And similarly, in 2020, compared to untreated chick, all these like first ever group 3A capture insecticides, they didn't reduce significantly for the nodal injury scale or like percent of lodging. So these data suggest pyrethroids is not very effective for management of corn rootworm. And finally, we check the different insecticides for management of corn rootworm. So we have like group 3A, group 4A, and group 1B. So if we look at the 2020 data, so we can see only like Index and Aztec, they can significantly reduce the damage for nodal injury scale as well as lodging compared to untreated chick and those like group 3A and group 4A insecticides. And in 2023, we increased many more like insecticides, and similarly, and we only found like Index and Aztec, these group 1B insecticides provide the most efficacy compared to other insecticides for management of corn rootworm. And in 2024, we repeated this data. However, if you look at the bottom node injury scale, you can see, so the dashed line here is the economic threshold. All the treatment, including control, they are below economic threshold. So that means the pest pressure was significantly low during 2024. So if we look at the precipitation data from 2020 to 2024, and we found that during late May and middle June, we have significant rainfall. So lots of plants in the test trials were flooded. So these too much rain or flooded cornfields will kill the corn rootworm, either egg or larvae, because during late May and June, it is an important time for those eggs to hatch in the cornfields. And finally, we summarize the relative control efficacy for the same insecticide across different years, and we didn't find any significantly reduced efficacy for those group 3A and group 1B insecticides. That means these insecticides still effective, ranging from 2020 to 2023. So finally, for rootworm, I'd like to talk a little bit about our insecticide seed treatment. Most of these seed treatments are from group 4A neonicotinoids, and the high concentrations were marked for management of corn rootworm. For example, we have thimerosal and chlorantraniliprole at 1.25 can be used for management of corn rootworm. So in this study, we have two objectives. This is one of my master students research. So first, we try to understand the different concentrations of seed treatment we use thimerosal to understand their control efficacy for corn rootworm. And the second, we try to understand the high rates of all the insecticide treatments in the market for managing of corn rootworm in both BT and non-BT cornfields. So for first study, understanding different concentrations, so we have BT2B as non-BT, and we have Smart Stack with cry-BT proteins and Smart Stack Pro with both cry proteins and RNA technology. So for insecticide seed treatment, we have yellow one untreated and 3 different concentrations for thimerosal ranging from 0.25 to 1.25. If we look at the figure here, so y-axis is a node injury scale, and the x-axis are the different BT and non-BT traits. For Smart Stack and the Smart Stack Pro, we have significantly lower damage. That means these BT traits are still very effective. And if you look at the non-BT, and you can see here, the control and the low and the middle concentration of the thimerosal, and we have no differences. However, for the highest concentration, 1.5, we have reduced the damage. So that means the highest concentration could provide some efficacy for management of corn rootworm. And in the second objective, and we evaluate all the high concentrations, and this time you include another BT traits, BT4 Pro, which contains Cry3BB1 and the RNA technology. And for insecticide seed treatment, we have untreated blue one, and we have thimerosal 1.25, chlorantraniliprole at 1.25, and also chlorantraniliprole. Similarly, if we look at the Smart Stack Pro, and the VT4 Pro, we can see significantly reduced the damage compared to those on non-BT. And if we look at the VT double, that's non-BT, and we didn't find any differences between non-treated and chlorantraniliprole, sorry. So if we look at the thimerosal and the chlorantraniliprole, and we can see either statistically significantly reduced or numerically reduced. That means these high rates can provide some control for management of corn rootworm. So for summary, for chemical insects management, as we mentioned, the group 3A and the group 30 are not very effective. And the organophosphate, group 1B, they are most efficacious soil insecticides, either in granular or liquid for corn rootworm control. And the seed treatments of either cruiser or puncher, they can provide some protection at highest traits, but not at low rates. And when you use these chemical insecticides, we need to consider the field problem, field situations. If you have resistant problems for these insects, so what's the efficacy over there? And also if you have precipitation, too much rain, so what's their impacts for those insecticide treatments?
So Fei, we did have a question come in, just kind of asking about the seed treatments. Basically, are they as effective as our other options there, or is it kind of secondary tier, or how would you approach that in terms of how reliable are the seed treatments are? Like you just mentioned some here with some issues with precipitation and whatnot.
Yeah, as I mentioned, for insecticide seed treatment, and we only see efficacy right now at a high concentration because our test field is high population density for Conlutum. It's a nursery. So in the experimental station at University of Minnesota. So for growth fields, and you need to understand if your pest pressure is high or medium or low. Probably for medium pest pressure, you can have some effect. And also if you are and we can see all the BT traits in our test trial are fantastic. That means our field, the populations are susceptible. But for growth field, we don't know if you have resistant problems to BT traits. Additional these high rate insecticide seed treatment probably can help for control of these resistant insects. So it's exactly field specific for management of cone rootworm using insecticide seed treatments. And if I have time, I would like to go through another pest. It's an old pest, and we call it European cone borer, and it's a major target pest of BT cone. And the larval stage is responsible for the crop damage. And as you can see from this picture, and this is the larvae, they cause a stalk break. And historically, before 1996, the adoption of BT technology, this pest alone can cost about $1 billion in yield loss and management costs. So in 1996, we used the BT technology, and since then, the ECB population was significantly suppressed. If you look at the figures here, so the red circle one are the populations density after adoption of BT technology. And you compare these to previous ones, and you can see significantly reduced. That means these BT technology are very effective for management of ECB. So currently we have CRY1 and CRY2 BT proteins in the market for management of European cone borer. So right now, games are changing. Unfortunately, in 2018, in our neighboring countries, Canada, they found the CRY1F resistance in Nova Scotia. And then during 2019 to 2020, they found that the CRY1F resistance expanded to other areas. And in 2023, they found a resistance not only to CRY1F, the ECB developed resistance to all the available BT technology in the market in Canada for CRY1AB, CRY105, and CRY2AB2. And more concerning, in 2023, we found the first cases for practical resistance of European cone borer to CRY1 and CRY2AB2 in connector. This marked the first case of BT resistance in US. So there are several reasons driving the resistance of ECB. For example, we have long-term use of BT technology, and this will increase high selection pressure for BT resistance in this pest. And also adult of ECB is highly mobile. So once resistance is discovered or established in one area, so these adults can travel long distance and distribute the resistance alleles around the landscape. So that's the reason why do we need to care about the resistance. As we mentioned, the resistant populations can migrate from Canada to US. If you look at the map here, so these red ones, circle ones are the initial resistant problems found in Canada, and then we found problems in Connecticut. So these between Nova Scotia and Connecticut, it's very close. And if you look at here, Manitoba, and it's close to Minnesota. So these resistant populations could have high chance to be here, in the US, in the Corn Belt. And also, ECB is significantly suppressed. That doesn't mean we don't have ECB populations in the landscape. And during 2023 and 2024, we still found some hotspots in Minnesota field. So for example, in 2023, in Martin County, we found one field with almost 6% infestation. And in 2024, in one field in Clearwater County, almost 90% of the plants in the field were damaged by European cone borer. And this is a field in 2024. So the grower thought it was cone rootworm damage. And when we visited over there, all these are the above ground symptoms. So we we check the damage, and we found that these are the typical damage by European cone borer. So we split the cone and we collect lots of insects from the field. So what we did, we collect these insects from the field and we do the bioassays with Bt proteins in the lab. So here we use all the Bt proteins in the market, CRA1F, CRA1B, CRA105, and CRA2AB2. We did data bioassays, incorporated these Bt proteins. And here is our data. And for CRA1 Bt proteins, we test the CRA1F, CRA1B, CRA105, ranging from 3,000 to almost 6,000 insects, and we didn't find any survivors. That means all these CRA1 proteins are still very effective for management of European cone borer. However, if you look at the CRA2AB2 Bt protein, in 2023, we tested 800, and in 2024, we tested 4,000 insects. And we found 10 populations or 10 families showing highly resistance to CRA2AB2. That means the CRA2AB2 resistance is significantly high in the field. And then we test the levels of these resistant populations. If you look at this map here, so the y-axis is a mortality, and the x-axis are different concentrations of CRA2AB2 Bt protein, and the black line here is the susceptible insects, and you can see at the highest concentrations from 360, you have 100% mortality for the susceptible insects. However, for these colorful ones, these are resistant populations from Wisconsin and from Minnesota, and you have very low mortality, especially for the bottom blue one and the red one. This is one population from Minnesota and one population from Wisconsin. We found almost no mortality, even at the high concentrations as high as 5,400. So all these studies suggest these populations of European cone borer are highly resistant to the CRA2AB2 Bt protein. In addition to the lab bioassays, we also did some field survey. So this is the field survey for Minnesota, as we mentioned. So most areas we have low pressure, and the insect for ECB is still low in the landscape. However, we have some hot spot. These colorful ones, we have some hot spot there. And similarly, for our neighboring states, Wisconsin, they also did the European cone borer survey during 2024. They tested a total of 162 fields. And similar as we observe in Minnesota, most locations, we have very low pressure of European cone borer, but we have 15 fields, almost 9% of these 160 fields with hot spot. So if you look at the specific of these fields, and you can see some fields have 88%, 84%, and even 92% infestation. And specifically, we found one field, and we found positive with CRA1AB Bt proteins. That means the ECB, European cone borer population, is developing resistance right now in the field. So for summary of ECB study, and we found resistance to CRA1 Bt protein is low. That means this technology is still effective for management of this pest, and the resistance to CRA2 is high. So that means right now we only have CRA1 technology in the market, or in the pyramidal Bt cone hybrids. So that means selection pressure is significantly high for these CRA1 Bt proteins, and these CRA1 are at risk of resistance development. And the overall population is low, but that doesn't mean we don't have any risk. The risk is resistance. As we mentioned before, once the insects establish resistance in the area, so these resistance can develop very fast and spread area. So this emphasizes the necessary to continue insect resistance monitoring. And right now, this is a top priority for the seed industries and the EPA to keep the continued efficacy of these Bt technologies for managing this old important insect pest. So these are the new pests we found the first time in Minnesota in 2024. The first one I would like to give a rough introduction is cone leaf hopper. So these are the pictures we took in the field in Minnesota, and you can see these insects. Maybe it's not very clear, and these are the cone leaves. So a little bit more introduction for this. So as I mentioned, this is the first detection of cone leaf hopper in Minnesota in 2024. It's from Hemiptera. So this is discovered in September 2024 in a field farm at the St. Paul campus of University of Minnesota, and we found like significant infestation and damage at V4, V5 stage compounds. Actually, this is like a random. So this is a trial plot not for like insect pest management. It's a trial plot for studying the frost-resistant corn hybrids, and we traveled over there and we found a lot of like plants were damaged by this species, and we bring these insects back and checked, and we found it's a new species here. So this is the adult of conleaf hopper. So it has like 3 different stages from egg, nymph, and the nymph has like 5 different instars and adults. So the most significant damage by this conleaf hopper is not by the pest itself. It's by the diseases they can like transmit. They can transmit 2 different bacteria and 2 different viruses, and we are resulting like we call it red stunt, and resulting significant yield loss. And you can see these like pictures here. They cause like symptoms of red stunt. Right now, we don't have any like management strategy here in Minnesota, but these are based on the published studies in Brazil and southern US. So seed treatment looks like very effective for management of conleaf hopper, and also like during the season, if you have lots of infestation, and you can also use like foliar applications. And Sivanto looks like good, and also those pyrethroids and organophosphate works well based on the like studies from southern states. Except in addition to like conleaf hopper, we have another new pest here, like in Minnesota. It's also like first reported in 2024. It's a corn silk fly. So this is not a pest for field corn. It's a pest for sweet corn. So we also found this pest for the first time in September 2024. And when we check our like sweet corn plot for BT resistance monitoring for corn earworm and European corn borer, and we try to find some like Lepidoptera insects, and we found we opened the ears and we found lots of damage. But for some traits, we found these like red circle ones here, and these are not like Lepidoptera insects. So we collected these insects back and identify in the lab, and we found that it's a new insect, is corn silk fly. And this is mostly reported and causes significant damage for the sweet corn industry in Florida. So I think with that, I would like to thank our like sponsors, different like seed companies, chemical companies, as well as the Minnesota Corn like research and promotion council support lots of projects for these like studies, and as well as University of Minnesota extension program. And finally, I would like to thank my students, my postdocs, and they all contribute significantly for making these like projects. And with that, I can have time for taking any questions. And thank you.
Right. Thank you, Dr. Yang. We do have quite a few questions that came in here, so I'm going to try to get to as many of those as I can for folks here. First one was going back to corn rootworm, multiple crop rotations. So let's say someone has corn, soybean, alfalfa, and small grain. Would that especially help in control for westerns or northerns? Kind of how much rotation is really going to help people out compared to, say, a corn soybean rotation, or especially the worst case scenario, corn on corn rotations?
So as I mentioned in the talk, right now crop rotation is still the best management strategy and probably like the cheapest and effectivest like management strategy for corn rootworm management. Although we have some like extended diapause that's only for northern corn rootworm, and we firstly documented the western corn rootworm rotation resistance. Those are just the small areas. So for those areas, maybe you have some problem with like rotation, but for most other areas, as you mentioned, for the like our yellow stick trap data, rotation is still the best effective way for management of the like corn rootworm, because like as we all know, the corn rootworm larvae, they can only like survive on the corn roots. By rotating to other non-host crop, these larvae can be killed. And even in some areas, you have like extended pause. If you do like 2 years or even 3 years rotation, you can kill almost all the, like most of the northern and corn populations, even if you have some extended pause problem there. Because like most of the extended pause, like they have 1 year or 2 years or 3 years. If you do like a long time, so these extended pause can be ruled out from the fields.
Kind of a follow-up to that, especially for the northerns with extended diapause. what percent of eggs remain, say, 2 or 3 years after corn? Is it close to 100% die off after, say, 3, 4 years, or kind of what do you want to set for your threshold on that question?
So I don't have like specific data for Minnesota because if you wanted to document the percentage of the northern congrural extent diapause, you need to take the populations collected from the field in the lab and just let these eggs hatch year by year. Probably like you need to run this experiment for like 3, 4 to 5 years. And however, we are starting this kind of study now in the lab. You collect some northern congrural worm from the field, and it takes a little bit time for our Minnesota population. But based on the data from Illinois, so they found like almost 50% of the northern congrural worm, they can hatch like first year, like a regular diapause, and another like 30, 20% or 40% the second year, and then the remaining like 3 years or more. So most of the like populations will hatch like during the first 2 or 3 years. But these like I think it's closely related to the like a management strategy, because if you do like a rotation very long, right, and these like insects of congrural worm, they can adapt to the management strategies, as we can see for all the BT traits, crop rotation, chemical insecticides. So that means we need to diverse the management strategies, not just rely on one control strategy.
All right, another corn rootworm question. Do in-furrow or other insecticides, they're asking if it has low or medium effects in corn rootworm pressure to keep them from increasing. So you mentioned some insecticides earlier. Do you want to comment on what are the in-furrow applications doing specifically?
Yeah, so as you mentioned in my talk, we did these infected insecticides efficacy tests from 2020 to 2024, 5 years. So we have like a very full coverage with like high density, low density, and a medium density. For whatever like density, and we can see those parasitoids from group 3A, they are not highly effective for management of congruent worm. And for the most effective one is organophosphate for those group 1B, like Aztec, and so those like are very effective for management of congruent worm. And also, if you want to use like the soil insecticides, so it depends what kind of management strategy you use. So not just like use like those insects as insurance. So if you do crop rotation, as I mentioned, it's not necessary to, if you have like heavy populations of Western congruent, it's not necessary to use like soil insecticides, because if you use like frequently with high concentrations, you may create resistant problems, and these like products will lose efficacy in your area. And if these like, especially for northerns, they can travel long distance, and these like resistance can spread into other places, and it will cause a problem across the state. So right now for like efficacy of soil insecticides, so you need to like determine those based on your like field specific situations.
All right, another question. This is getting with talking about conservation practices such as no-till and cover crops. On our corn insect side of things, does that help or hinder insect control at all that you know of?
Yeah, for sure. The cover crops provide many benefits, right? So it has, you can keep the higher health and have like a weed control, erosion control, and also sometimes bring lots of like beneficial insects. However, these like cover crops sometimes they can cause problems. So they can provide some like the hosts like a shelter for the insects can migrate here like armyworms and cutworms. And also sometimes it could create like we call it like a green bridge for the pests. So make these pests can persist between cash crop cycles. And typical example is aphids. So those host on cover crops, and then later they can move to the soybeans.
All
And
right. Oh,
yeah, and
go ahead.
also like for cover crop, I think like it's very important, and you choose like the correct like the crops over there. Try to avoid those like cover crops that can host like key crops in your area. And also like termination is very important. Normally we suggest at least 2 to 3 weeks before planting to break those like we call it like green bridge.
All right. I had a question on your corn silk fly. They're wondering where has it been in the state? They're asking especially about northern Minnesota, but where has that been found so far?
So this is found in Rosemont in the like a research station in Minnesota. So it's like found by accidentally. So we as I mentioned, this study is exclusively for managing like a cone earworm and the European cone borer using sweet cone. But when we check results, we accidentally found those like silk cone flies. So I'm not sure whether other places like they have these kind of problems. So probably we when you sample your like sweet corn field this year, you can take a look. So as far as I know, these are not local populations. Most of these populations should come from like Florida.
All right. We have Bruce Potter commenting just a little bit here too. I see he's just mentioning that the selection pressure for those soil insecticides often could be driven by foliar applications in corn or maybe other crops, especially if those corn rootworm adults are getting exposed there. So that also wanted to mention we had some questions coming in about chlorpyrifos. You mentioned the organophosphates. There will be some links provided as well, but the short update on chlorpyrifos is that EPA's had some announcements recently where if you want to use it in 2025, you have to buy it by April 30th, and it has to be used by June 30th. So it's basically an existing stock order in that case. So that's the update we have for that. I know, Fei, you provided some links. I think it was Kelly Solutions. You can look up what products are registered in Minnesota. So some of the products people might use Lorsban. That one isn't available as one of the common trade names, but there are some other ones that are still on that list. So that's the update there. I want to get a few more questions in before we close things out for folks here. I had a question about conventional corn. Can we go back to conventional corn while still managing for corn rootworm or other insects in the mix too?
So as I mentioned, like it totally depends on your like a specific like area, specific fields. So if like take it like a corn rootworm, like for example, if you do rotation very well and most like a species in your area, Western corn rootworm, for sure you can do like a conventional corn and you plant like a soybean, alfalfa, or wheat in previous years, and this year you can do conventional corn because like most of these species can be like the life cycle can be disrupted by the like rotation. And if we don't, and also like if you don't have rotation resistance in that areas, and the conventional corn could be like very good and strategy.
Another question related, well, we were talking about winter temperatures a little bit. One of the questions was about, we had below average snow cover. So how is that affecting our insect populations? We mentioned corn rootworm a little bit. How about European corn borer, some of these other insects we deal with in corn in terms of winter mortality?
So for the first part of the question for corn rootworm, so keep in mind everything like you try to manage for corn rootworm like you did this year is for the next year. So if you look at the management strategy for 2025, so we need to go back for the like monitoring data in 2024. So in 2024, in most areas, like in Minnesota during late May and middle June, we have like heavy rain, heavy like precipitation. So lots of the cornfields were flooded. So as I mentioned in our study, so those like fields and you will have like a less insect project. Probably those eggs or larvae were killed by the flooded like environment. So that make the adult population is low. And also during late season, during August and September, that's the peak activity of the corn rootworm. So we experienced a very dry like environment and probably like historical drought like conditions. So that means most Western and Northern corn rootworm, they typically ovipositor their eggs during like 4 to 6 inches, but below the soil or surface. Okay, so during this last year, the dry years, they can sometimes they can go as deep as like 12 inches, but that kind of percent probably low. And also like with low snow coverage this year in some areas, and also we experience a very extreme cold temperature. So if you take all these like situations together, probably we have like a low like insect pressure in some areas, as I mentioned before, for these like corn rootworm populations. And like for the second part for European corn borer population, so it depends also on your like areas and also whether you do like tier or no tier, because most of the like European corn borer pupae and live No, no. I mean the larvae. They will go diapause, like in the soil or in the the debris of these crops. So if and also depend on their cold tolerance. So I don't have like specific data for like a European Cambora. Probably with this like severe cold with no soil coverage and no temperature control them. So they may suffer some damage. And overall, as I mentioned, the European Cambora population is still significantly low over the state. We only have a few spots with heavy populations.
All right. I have one last comment that just came in from one of our MDA folks, Trisha Leaf. This on chlorpyrifos. So there's been many changes. So we're also getting updates on the fly with some of this too. So here's kind of the new update. There will be some products available for chlorpyrifos beyond June, but they're going to have some updated labels coming up for that one, a lot more restricted uses. So that's kind of the quick update on that one. I won't be allowed on corn after the June date, only soybeans, sugar beets, and alfalfa, and maybe a few others in the mix there. So again, with that, Fei, thank you again for presenting with us today here and giving us an update on what's going on in the corn insect world. And everyone attending today, thank you again for attending this Strategic Farming Let's Talk Crops program. Again, thank you to our sponsors, Minnesota Soybean Research and Promotion Council, as well as the Minnesota Corn Research and Promotion Council. And next week we will be here again on Wednesday. So we'll have, same time, same place, and we will get you more information on what's going on with some of our other crop issues in the future here. So again, with that, thank you again, everyone, for attending today.